Welcome to the summer 2016 edition of the student exit presentation for the Autonomy Incubator. Angelica Garcia joined us this summer for the first time from the University of Central Florida. She was an important part of our HOLII GRAILLE team, looking at the modeling and simulation, as well as the immersive environment in which a user can interact with the intelligent agents in the system. So please welcome Angelica Garcia.
Thank you guys. As Danette said, my name is Angelica Garcia, and today I'll be talking about my work this summer in the virtual reality simulation for drone trajectory generation. So very quickly, a little bit about myself. Like I said, my name is Angelica Garcia, not Pickles, but now you remember my name. I'm from the place where dreams come true, and that's Orlando, Florida, not California, sorry. I have a bachelor's degree in aerospace engineering from Embry-Riddle Aeronautical University in Daytona Beach, and I'm currently going for my master's degree for modeling and simulation at the University of Central Florida. So, like Jeremy and Lauren spoke about earlier, we do take part in the Agile approach at the Autonomy Incubator, and this is just an example of my quad chart. This would be my final quad chart for the summer. I will quickly go over the objectives because it summarizes my work this summer. And throughout my presentation, I'll highlight on the approach and the milestones, and I will highlight why some milestones are red and the reasoning behind that. So very quickly, my objectives were to develop a Unity application and integrate it with two head-mounted displays, which were the Oculus and the Vive. Develop a terrain database, including a typical and unusual terrain. In Unity, we wanted also to simulate drone real physical movement in this terrain and incorporate hand gestures for the drone trajectory controls in the virtual reality world. We also wanted to integrate the simulation to the DDS framework for data transfer between Unity and the trajectory generator. And ultimately, we just wanted to simulate a drone flying in a virtual, usual or unusual terrain, using hand gestures to edit and modify this terrain until it was validated and the trajectory was approved for the actual drone to fly. So beginning this summer, I was tasked to pretty much explore virtual reality and find out what headset was the best headset, what we could do with it, and how we would incorporate it into UAV simulation. It took it upon myself to pretty much find the right computer, which was very, very difficult early on. All I had was a laptop, which the graphics card wasn't very strong to even turn on the Oculus headset. So that was an extreme challenge. I ended up staring at this error for a really long time once I got a lab machine that hadn't been updated since 2014, but it was something, so we made it work. We finally got it completely and successfully updated thanks to Kevin. There was a little tweaking going on for a while, but we got it to work. Once everything was set, we successfully downloaded Unity and all the Oculus software in order to run a simple demo. At the time, we didn't actually have the HTC Vive headset, and we weren't able to download any of the software yet because we didn't have the headset, and some of the network in the center was kind of restraining us from getting the download through for Steam. So we held that off for a little while until a new computer was purchased. So most of my work was based off of Oculus and Unity. So at the start of the semester, as soon as we got the computer set up and running, I downloaded Unity, hooked up the Oculus, and began learning Unity in C#. To this point, right before arriving here at Langley, I had no idea about C#. Mind you, I did have programming experience, but I didn't know what C# was or how to code in it. I had some simulation environment development prior to coming here, but I didn't really have any experience with any game engines. So downloading Unity was the start. So this is the typical Unity interface. It looks very simple, and it actually is. It's very user-friendly, and there's a lot of resources out there to help you get started, which was awesome because I got going pretty quickly. So once we got everything downloaded and installed, I developed a simple Unity game with physics. So that's the top image. That's a little sphere that rolls around the table and collects the spinning blocks. Once I realized that that was very simple and I could do it easily, I researched ways into adding real terrain imagery and elevation into Unity for application purposes, because ultimately we wanted to see how a drone would fly in known terrain and ultimately unknown terrain. So I successfully got the Langley imagery through GIS, and I had height map information from the USGS website. But suddenly I realized that Virginia in this area is very flat, and the only difference was bodies of water that you can tell are very clear. So instead of going through all the trouble of collecting all this height information, processing all the data, I realized that I should just leave a flat terrain and overlay the imagery, the actual real imagery, to my terrains. Once I realized I could do all this, I went on and I researched plugins and actually integrate the Oculus with these applications. So that way I'm not just staring into a 2D screen, but I can actually immerse myself in this world. The top image, you can see it's my first scene in Unity that I was able to view in 3D. I just added some trees and some random grass areas. They're very sparse, but it was really cool actually putting the headset on for the first time and seeing just trees in the virtual world and immersing yourself fully in it. The bottom picture is just proof of concept that the Oculus actually was running and working finally in the computer. So I was very excited when I saw that through the headset. So once I integrated a simple application with the Oculus, it was go time. I created a basic terrain database from the real GIS imagery, which included a back 40 terrain. I added some grass, some trees, some road texturing. I played around with some models, but decided not to spend too much time developing 3D models and focus just on the simulation portion. Throughout the Holy Grail integration, we realized that one of these terrains was actually the wrong one that the spiral was over. So I had to backtrack a little bit and redo some of the terrain development that I had already started. But we'll go into more detail later. So once I created the terrain, it was time to integrate an actual drone into the simulation. And this is an example of the rotor movements in Unity. Thanks to Javier and his team back from school, this process was actually a lot easier than it should have been. It was a basic script. We already had the models and just applied the movement to all the rotors, which was very easy, and it looks really awesome. As soon as we integrated the drone into the simulation, it was time to explore what else we could do with hand gestures. We had a couple of leaps laying around, so we attached it to the Oculus and realized that we could do really cool stuff with it. The two left images are actual images of the application that Javier provided us with skins overlaying the leap generation models. So you can actually move your joints and your hands, and you can simulate it virtually following your own in real time. We could actually use that as well to show controls, hover controls over hands, and select different qualities for the application to complete. The bottom right picture is just a really cool game we downloaded and we had a lot of fun with, just as a proof of concept that the Leap and the Oculus work perfectly together, and it's really awesome and immersive, and it shows a lot of the capability that can be added to simulations later on. After all that research was done and all the proof of concept was finished, we assembled as the Holy Grail team, and we realized that we needed to render some splines in Unity. I didn't realize how difficult this was going to be until we actually started. At the beginning, I was able to generate splines in the editor only, which was a challenge because I wanted to see the Bezier curve overlaying in the terrain as soon as I hit play, not just in the editor mode. So we struggled with that for a little while. This was the first run at actually rendering a spline after the drone flew the trajectory. But with a lot of help from Jacob, we got our awesome spline rendered in the runtime mode, and following the drone trajectory is the trail, just as proof that we can have both. So then we researched and implemented the drone object movement following the spline trajectory. So now when you hit play, you can actually see a rendered spline, the spline of the trajectory that's supposed to fly. And as the drone moves through the spline, you have a trail render following the trajectory where the drone has already flown. I also added keyboard and control use for the scene. So if you're sitting there with the Oculus mounted, you can move around the scene in kind of a flyover mode. You can walk around the terrain or fly over the terrain and see the trajectory from wherever you're standing. So this is an example of the first trial of our line renderer following the trajectory. So it's the trail rendering. You see the drone is moving and the user can move in the scene and fly over the entire terrain. But our limitation here was that you can only trail the drone with this line. You couldn't see the line before the drone actually flew it. And then we actually got the line rendered prior to the drone moving. And you can see the user can easily move around the scene and check out the drone position, where the drone should have flown and where the drone is flying. Ideally, we'd want to simulate this in any type of terrain. It doesn't necessarily have to be over real Langley imagery terrain. It could be a volcano, it could be in the forest, it could even be Mars. It's very easy to change terrain and implement it once you have all the data. As you can see, the user can see back to where the trajectory started and where it's finishing all in one time. And finally, I got my new computer, which was really exciting. It just so happened that it was right before the flood. So it took a little longer to transfer everything to the new computer. But I did get to integrate one of the detailed terrain databases with the simulation. So as you can see, the user is flying over a detailed terrain with grass and trees, which in the old machine, every time you put the headset on, the image would flicker and there was a lot of latency between the displays and the movement and the head movement. So it was really cool and exciting when we could see this, and it was amazing. So new graphics card is cool, it's great potential. I wish I had it sooner. We could have done a lot more, but the summer's short. So remaining work, I would love to automate the spline generation process. I would like to integrate DDS communication with Unity and have that back and forth communication with the trajectory generator. And that kind of ties in together, automating the spline generation. I'd like to implement trajectory modification through hand gestures now that we know that we can't have hand gestures in realistic skins. In virtual reality, we can show those control points that are being generated from the trajectory generation and move them in the virtual world and edit the spline that's starting that communication back and forth with the trajectory generation for validation. I also would like to set up the Vibe hardware. I don't know how feasible that would be in 2 days, and software to compare the performance of the Oculus, which we have been working on all summer, and the HTC Vibe, which we hear has a lot more potential. There are a lot of applications for virtual reality in simulation that I have discovered this summer. We can not only simulate just the trajectory, but perhaps simulate the actual physics of the drone moving through any terrain, avoiding obstacles in different weather, in different environments. So that was really exciting to actually get to work on and see the potential for all this new technology. Lessons learned, hardware is really hard. Hardware and software is even harder, trying to tie them all together. Computers have moods. My computer shut down during a demo twice, out of nowhere. And virtual reality, once again, is very powerful. It's awesome, it's fun. I know we all had a great time playing with it this summer. And in the future, it will run the world. So I just want to thank everybody. I had a great time this summer. The entire Holy Grail team, you guys are awesome. We had a lot of fun. And it was a great project, so thank you.
Any questions? talk a little bit about, so the VR community has been working for a long time sort of on the visual side, right? Since the 90s, where gaming was the killer app that really moved video cards, video processing power far with GPUs, right? But we're at the beginning of a new revolution, right, in VR. Some of the hurdles that we hit had to do with really feeling immersed in the environment, not just visually immersed, right? And you hinted at something where you talked about being able to interact with the trajectory. What would that look like? Like, what do you think would be an effective way of doing that? What technologies do we have available now to help us do that? And what do you think the gaps are? You know, if you were queen and you could invent any technology or bridge any gap, what would that be?
In my ideal world, we'd have this awesome room where we can just simulate in VR. We'd have something like the Leap, which is a great technology that we have now, and a headset, not necessarily the Oculus or the Vive, but one strong enough to handle really great graphics where you feel like you're there. Right now, with the Leap and the Oculus, when you see your hands, they're pretty real, but you're kind of limited to certain types of hands. In the example I showed, it was a man hands pretty much. So ideally you'd have a huge database of models and really good graphics just for anything really, where you can pick and choose and adapt it to what you're trying to simulate. Not only just the graphics and immersing your hands, but also having the audio would be amazing. A lot of times when I'm sitting there looking at the simulation and seeing the drone flying, yeah, it's immersive, it's cool, I see it, the graphics are great, I can see my hands, but I can't really hear anything, so that takes away from the realism as well. In terms of modifying the trajectory, some tactical feedback would definitely help. I can sit there and move things around. In the game that we showed with the cubes, you can make the cubes and you kind of have a little sense of, okay, I'm making a cube, throwing it around, but it's not that real until you hit a keyboard that's there and you're like, oh, okay, just kidding, I'm still in the game. So having maybe some vibrations or something that gives you some tactical feedback that you're actually there, that enhances more than just your vision and your senses, would definitely make that environment a lot more realistic and a lot more stronger.
So you hit vision.
Yes.
You hit proprioception, realistic, right? My hands are where I can see my hands, where I think they are. You hit oral feedback, you hit haptic feedback. What about, so we did a subscale simulation, right? And in fact, you were interacting with the world in almost a subscale way. I can't necessarily, but I might have miles and miles and miles of ground to cover. What about the idea of this person being fully immersed in the environment and walking around or flying around? Do you think that the keyboard approach or some sort of spoken approach is adequate, or is there something else you'd rather see?
For walking around.
For moving around in the environment. So I'm going to go grab this trajectory, but it's 10 miles up in the air.
And that's a little harder to answer because I have seen some studies done about movement in virtual reality. Different people react to virtual reality different ways. So me moving you to a specific area in the simulation, you might react differently than me moving you to actually moving you to that area. So if you're moving yourself to, let's say, 50 feet up in the air, might be different than me slowly zoning out the scene and appearing in a different scene. So ideally, as of now, I wanted to incorporate those fading in, fading out aspects of the simulation to move in this infinite terrain. I didn't quite get there, but I did want to explore the idea of how different people would react, either fading in and out of terrains and areas, or actually physically moving in that terrain or area, or being able to control themselves as a flyover from one point to the other. So I think it just depends on how different people react, and I think it's something that definitely needs to be researched now that we have so much capability for all these simulations.
So you'd agree that's an open research
yeah,
question?
definitely.
Less applied even than some of
Yeah.
what you've done.
Yeah.
So these aren't solved problems.
Right, a lot more human interaction with the simulation.
Thank you, Angelica.